Welcome to the workshop. Today we want to take a look at section 3 of the appendix. So this section is actually on methods of proof. So in this section we present several proof methods and we see several examples as well. Now the main thing that you want to keep in mind when we consider proofs is that all we're looking for is a justification of why something is true. Sometimes it's just a little bit of algebraic manipulations that we say, hey, look, this thing is true because when I change this into that, we see what we're trying to show. It is essentially all that ever occurs. Well, frequently that's what occurs, I should say. So most proofs that we work with will be implications. If this is true, then that is true, is the idea, okay? And that's what we want to work with primarily. So let's take a look at our notes, and the idea of direct proofs is what we'll take a look at first. So when we're taking a look at an implication, right, we want to show an if-then statement is true. So in general, when we're talking about a statement that we want to prove is true, these statements are called theorems. So a mathematical statement that is true is sometimes called a theorem, and usually it's in the form of if-then. If we have these things, then we know that this other thing is true, is the idea, okay? In an if-then statement, within the context of a theorem, the if portion is called the hypothesis and the then portion is called the conclusion. Whereas previously, right, the if portion was called the premise and the then portion was called the conclusion. So just a few details that may come up as you're reading the text. But what do we really need here? Well, we want to show that the implication is true. So of course we don't want to have this situation because that's when the implication is false. So we're just looking to have one of these other three scenarios. Now, if the if portion is false, then we know that the implication is true overall. So it's always true when the premise or when the hypothesis is false. So the only time that we're actually concerned about is this guy right here. When the premise or hypothesis is true, and the implication is true, then we want to show that, if we have that the premise is true and we have that the conclusion is true, we know the implication is true. So when we're looking at a direct proof, what we're interested in doing is assuming the if part, right? These are the hypotheses, these are the assumptions. So these, when we say P, we're taking a look at the hypothesis, or simply the assumptions of the theorem. So when we assume those hypotheses or we make our assumptions, then we go ahead and use some definitions, theorems, algebraic manipulations, well-known facts, whatever it is we use the premise or the hypothesis to bring us to the conclusion of the implication, right? And we say that, hey, this conclusion must be true. And when the hypothesis or premise is true and the conclusion is true, the implication is true. And that's all that we're trying to show here. And this might seem, this is pretty formal still. So our proofs themselves, when we develop them, we won't necessarily be trying to enforce such language. But what we will be doing is we will be trying to copy this form. We should indicate the beginning of a proof. This square box right here isn't put there for fun. It's put there to indicate the end of the proof. So, every problem that you do for me, if you're my student, if you forget to write proof, you're going to lose a point. If you forget to indicate the end of the proof, you're going to lose a point. Why? Because we need to indicate the beginning and end of a proof. It's just part of the formalities. And then what lies between is usually a book of what's going on. Of course, if you forget the beginning and end, hey, just that's not a big deal, right? But you need to get what's in between right. And so we start off with the assumptions. We use those. We use well-known facts. We use definitions, theorems that have already been proven to find that the conclusion is true, which allows us to say that the implication is true. That's the idea. All right, so that's just the idea of a direct proof. What I'd like to do is I'd like to take a look at 2 examples of direct proofs, but we'll do that in the following videos. So I'll see you guys back in the workshop very shortly.